Thank you for joining us this afternoon for the first in a series of 6 of climate resilience classes, webinars that are being offered by the University at Buffalo, NYSERDA, and the U.S. Green Building Council. And at the end of the course, everyone should be able to go through these and understand these 4 different learning objectives. Also, before we get started, we just want to thank NYSERDA, who has sponsored not only this research, but also this webinar today, and the U.S. Green Building Council New York Upstate Chapter, which has helped with the promotion of this event. My name is Nick Rajkovich. I'm an assistant professor in the Department of Architecture, and we have here in our office here at the University at Buffalo also Hope Forgas, who is helping out with this event today. As I mentioned, this is part of a project that has been going on at the University at Buffalo and supported by NYSERDA for the last 3 years. And we're starting to report out through these webinars some of the different findings that we've had as part of this research. Since we do expect actually about 80 people to be on this call today, we just ask that you keep your microphone or telephone on mute during the webinar to eliminate any background noise that may be there. We also ask that if you do want to ask questions, that you use the WebEx chat feature to ask the questions. And also at the end, we will unmute folks and allow them to ask verbal questions. We'll try to get at those as we go along, but if you want to ask those WebEx questions through the chat feature, please make sure that you send it to all of the panelists so that Hope can see it and read it out to me. And finally, I mentioned that this is the first of 6 webinars in this series. The next session on climate hazards in New York State is coming up this Thursday at noon. If you like what you hear today, we'd be happy to have you join us this coming Thursday, and the registration is at the same site that you saw before. As part of this research, we've created a lot of different information. All of that information is listed at the website that you see here, ap.buffalo.edu/adapting buildings. We have a number of different reports that have been produced as part of this research. We also have some additional resources to help guide people. I know that we have probably the majority of people are joining us today from New York and New York State. Those resources are really intended and designed around New York State-related climate hazards. However, they really are something that can be applicable to all of the Northeast region and certainly places that have a similar climate. So if you're joining us from other parts of the country, while we'll be talking about things specific to New York State, we hope that you find the information useful and perhaps you can adapt it to where you live. So we're going to start to dive into the presentation here and give you a little bit of an introduction to this overall project. This webinar really is, again, the first in a series of 6. The next 5 are going to go into much more detail, but what we have here today is really the overview to all of those reports and all of the research. So climate change is something that is driven by the increase of levels of greenhouse gases, the concentrations of which are now 1/3 higher in our atmosphere than they were in pre-industrial times. I think many people who work in the green building industry understand how much buildings actually contribute to greenhouse gas emissions, and certainly there's a big push to get to net zero energy in buildings, net zero carbon in buildings. But while reducing greenhouse gases is critical and really one of the primary things that we need to be doing in the AEC profession, this course really discusses the impacts of climate change on the buildings, not the impact of buildings on climate change. We'll really be talking about how buildings need to become more resilient, how they need to begin to adapt to the changes we're already seeing in the climate. And this is because buildings need to work successfully in both the current and the future climate, and there's a pressing need to address a lot of other environmental concerns that go along with climate change as well. So this project that we'll be talking about over the next 5 webinars here is actually part of a larger set of studies that NYSERDA has done to understand how climate change is going to impact all the different sectors of New York State. We've been focusing just on the building sector itself. So climate impacts on buildings are going to become increasingly severe as the climate warms, and we expect that climate risks, since they're not similar in all locations, they need to be addressed on a regional basis. The ClimAID reports that NYSERDA pulls together actually breaks up the state into 7 different climate zones, and we'll be showing those on some of the maps a little later in this presentation. Climate change does create really challenging impacts to the building stock through things like extreme temperatures, extreme storm severity and frequency, and also changing precipitation patterns. And again, we'll be going and giving you a little bit of an overview about these things in today's presentation. But if you're interested in getting into this in much more detail, we'd ask you to join us on Thursday when we'll be going through climate hazards in a little bit more detail. So what is it about climate change? A lot of people start to talk about things like waiting for the next normal. One of the important things to understand is that we've been putting greenhouse gases in the atmosphere since the mid-18th century. And the climate is really not something that's projected to stabilize at a new normal within this century, but is expected to continue to shift over the coming decades. So the warming that we're already seeing now may extend for more than 100 years. So the idea that we're going to move to a new normal is not correct. There really is not a new normal. This suggests that we need to go through an iterative process to begin to work on climate adaptation. We need to make our communities resilient over the long term and understand that as we renovate or build to new standards, we need to take into account the issues of climate change. I think it's important to point out that it's not possible to be resilient to all of the issues that are potentially going to hit us. We need to do the best that we can. We need to work together as different disciplines to address these issues, but 100% resilience to all things is an impossible goal. And prioritizing adaptation strategies is something important to meet the most pressing needs of a building in a place at a time. There are no universal prescriptions to make buildings resilient. It really requires us to move beyond prescriptive approaches, to begin to adapt things to different sites, to different locations, and to understand how these buildings will perform over time. I'm going to briefly go through a couple of key terms. I'm going through the key terms because it's important to understand how these are used in the climate literature. In some cases, these terms are used a little bit differently than what we see in architecture or engineering usage. So adaptation, really the focus of these 6 webinars that we're doing, is the process of preparing for an intensified climate by making adjustments for the actual or expected events. Adaptation seeks to moderate harm, exploit any opportunities that we have, and to cope with consequences. A hazard is something that is going to potentially cause damage to a building or the built environment. Impacts are the potential effects a change has or could have on the building and its occupants. And mitigation, in the case as it relates to adaptation, is reducing the magnitude of climate change impacts. One of the key terms oftentimes talked about, and you see a number of conferences talking about these issues, is that of resilience. It's the capacity of a system, a socio-ecological system, to cope with a hazard event or disturbance, responding or reorganizing in ways that maintain its essential function, identity, and structure, while also maintaining the capacity for adaptation, learning, and transformation. Resilience is not 100% the same as adaptation. These are terms that actually go hand in hand. As we also look at terms like risk, risk is a product of the probability of a climate hazard occurring, the likelihood of an impact from that hazard, and the magnitude of consequences if that impact occurs. So something like a snowstorm event may actually not be a very high risk issue because it's something that we're used to seeing in the past, certainly in Western New York. But certainly over time, that risk is potentially going to increase. And finally, vulnerability is the degree to which buildings, occupants, and related social systems are susceptible to and unable to cope with the adverse effects of climate change. And one of the important things that we always need to keep in mind is that vulnerability is not distributed evenly through our buildings or through our society, that there are often portions of a city, for instance, where lower income populations can be that may be much more vulnerable to some of the impacts of climate change. So as we talk about the terms mitigation and adaptation, mitigation is something that has been described as avoiding the unmanageable, and adaptation as something as managing the unavoidable. When we think oftentimes and talk about this in the building industry and we use the word mitigation, it often is related to greenhouse gas emissions and mitigating those emissions. That's really, again, to help slow global warming, such as through sustainable building design or energy efficient measures. What we're talking about and what we'll be focusing about is actually to talk about how buildings prepare buildings for intensifying climate conditions to improve building performance and to reduce risk to expected hazards. Many energy and climate-related design and operational decisions for buildings are governed by building and energy codes, which set prescriptive or performance-based requirements. The important thing to point out for some of these things is that they're based most often on a location's historical climate data. Most of the time when we're actually working with these codes and standards, they're backcasting and looking at the last 30 years of data to understand what the conditions may be in the future. But what's important about this is the future is not exactly expected to be the same as the past. And as we move forward and begin to look at regulations to help change practices, we need to understand that these things are reactive entities. In some ways, we need to move and look at the future. And because the construction industry is so strongly influenced by codes and standards, I think most people would agree that it's often slow to make changes. But codes are not going to be the only way that we begin to address climate hazards in the future decades. It's something that we really need to look at all approaches, things like green building standards, et cetera, to begin to move forward on this issue. So I want to turn from that brief overview of some of the terms and the brief introduction to this to begin to talk a little bit about climate hazards in New York State. And again, for those of you who are joining from outside of New York State, try to understand how these might relate to where you live or, how they might be something that help you with your own work. So to give a little bit of a background of New York State, it's a humid continental climate with a wide range of climate conditions. It's influenced variously by things like the Atlantic Ocean, the proximity to the Great Lakes, and mountainous regions. People talk about New York State as being one state, but really as you travel around, it's very easy to begin to see these 7 climate regions that go all the way from downstate by New York City, all the way up into the Adirondacks, and certainly to Western New York, where we are in Buffalo, New York. The annual temperatures in the state vary from about 40 degrees Fahrenheit on average to about 55 degrees Fahrenheit in New York City. So you do see some pretty significant temperature differences. Also, the statewide average for snow is about 40 inches per year, but it varies pretty regionally from more than 175 inches in places like the Tug Hill Plateau and in Western New York to less than 36 inches in New York City. We also see a pretty extreme range of heat and cold, certainly from well over 100 degrees to well below zero in northern parts of the Adirondacks. And from that comes things like flooding and other types of coastal storms. And I'll mention that coastal storms are not something that just happens downstate. It's something that certainly we see in places like Rochester on Lake Ontario and also in Buffalo on Lake Erie. When we start to look at some of the climate hazards, climate scientists at this point can say with a pretty high level of confidence that the future climate is going to differ from historic trends. So how we've worked in the past in terms of understanding that data from the last 30 years is not necessarily a great precedent for what we'll see in the future. Again, so we should not use and expect precise forecasts for things in the future. And as we go through and look at some of this, most of the time climate scientists actually put these into a series of ranges, which can actually be a little bit tricky to begin to incorporate into building design. But what we are trying to do is understand what the trajectory for some of these things are and anticipate that with our building design. To that end, appropriate design for climate change is something that'll be critical and need to work for that range of conditions. And again, those codes and standards may not be something that are updated immediately. We may need to start to work to get out in front of some of these topics. And because New York State has such a range of climates, there are a lot of different climate hazards and diverse geophysical characteristics. Strategies that may work in a place like New York City may not be appropriate in the southern tier or the Adirondacks region, or certainly in western New York. And as we see that climate change, it's again not going to reset. So the new normal is something that is dynamic, and we'll have to continue to work with our buildings over time to make sure that they continue to adapt. So the first in the series of impacts that we wanted to go through, or climate hazards that we wanted to talk about, are related to hurricanes and tropical storms. It's probably fair to say that a lot of things shifted for the building industry in New York State after Hurricane Sandy, which really was the most damaging storm ever to happen in New York State's history. By some estimates, it actually caused over $11 billion of damage, and certainly to the major economic center of New York State, really interrupted operations for a lot of different organizations. While these impacts from hurricanes and tropical storms tend to be concentrated in New York City and Long Island, they have actually caused damage across New York State. The damage that occurs is not necessarily just because of the storm surge or the storm actually coming ashore. Oftentimes, as those storms break up, as they move up into the northeast, it actually can cause torrential downpours and rain. Along with the rest of the eastern seaboard, New York has been experiencing a period of heightened hurricane activity since 1995. It's more likely than not that these intense hurricanes will increase in the North Atlantic, and intense precipitation from hurricanes will also increase as well. As we look at some of the impacts associated with hurricanes coming ashore, storm surge certainly was one of the biggest issues that came with Hurricane Sandy, the flooding because of the storm being pushed ashore. It's a type of flooding caused by wind-driven water during a tropical storm or hurricane, particularly if they occur at high tide. So something to keep in mind for Hurricane Sandy, it was actually not a very strong storm when it came ashore, but it came ashore at exactly high tide, and it drove a lot of the flooding that happened downstate. As we look, though, and we try to understand where those impacts are, again, looking across New York State, right, most of the damage has been concentrated in the low southeast portion of the state on Long Island and the city, but you can also see that there's been a significant amount of damage in places like the Catskill Mountains. But as those storms break up and continue to move up the coast, there's been a tremendous amount of flooding actually that occurs in upstate New York, and some of the damage from Hurricane Ike, for instance, caused pretty catastrophic flooding across the entirety of New York State. The second piece, second type of hazard that we're concerned about in New York State certainly is flooding. As we dive in and look at flooding, we have really different ranges of precipitation across the state, so between 30 and 50 inches of rain per year. Precipitation is something that's projected to increase in the coming decades, with the greatest increases in the northern parts of the state. One of the other critical things to point out about this is that a lot of the precipitation is going to come in much more intense rainstorms, having days that have 1 or 2 inches of rain per day or over multiple successive days. And this wetter climate definitely may intensify flooding and other hazards associated with it. Inland flooding is something that has occurred in every New York county, all 62 counties in the state, and it can also be caused by things like rain or snow melt beyond the capacity of a soil to absorb the water, and streams and rivers to remove it. In one of our webinars that we're going to have in 3 sessions from now, we'll actually go through and talk about specific details to begin to deal with all of this type of flooding events. As we start to look at what the future may bring related to increased precipitation, I mentioned that a lot of these storms may continue to fall in greater amounts. So as we look at what happens in the 2020s, in all of the regions, we start to see slight increases in the total number of days we receive more than 1 inch of rain in a year. But as we move into the 2050s, and then as we move again to the 2080s to the end of the century. In many places, these are projected to pick up quite a bit. So places like New York City, for instance, going from 13 days of rain over 1 inch per year to over potentially as high as 18 days of the year. In the really extreme rainfall events, the days when we have more than 2 inches of rainfall in a year, these are projected to continue to increase over time. As you look at a place like Rochester, New York, where we live in Western New York, we're going from something that's relatively consistent right now. We're almost into 2020, being in 2019. But as we look into the future, these begin to increase to the point where we're seeing at least one day a year where we're having these really intense rainfall events. Severe storms are certainly something that impacts the entirety of New York State. Severe storms like thunderstorms are something that are common all across New York State. However, they have the greatest frequency in western and central New York. These severe storms are likely to increase due to warming temperatures, and along with that, we will see increased precipitation. The physics behind that, basically with a warming atmosphere, there's more energy in the atmosphere and more ability for the air to hold more precipitation, hold more rain. And so as we see the atmosphere warm, we expect these things to increase over time. Although the precipitation increases that I showed in the last table are relatively small, seeing very great differences in the frequency, intensity, and duration of these events is certainly something that can stress our infrastructure systems. In places like Buffalo and Rochester, where we have combined sewer systems, this certainly can begin to impair the water quality in the Great Lakes. Winter storms, this is the area where Buffalo really stands out. Certainly something that may be counterintuitive with a warming atmosphere that we may see increased winter storms overall. As you look at the data to understand how these things, how precipitation works, the historic winter precipitation has been highly variable, so it masks some of the trends that we've actually seen in total rainfall or total snowfall over the course of the year. But again, because we're on Lake Ontario and we're on Lake Erie, as we see changes in the ice cover on the Great Lakes, it suggests that more lake effect snow will increase in the coming decades. And certainly if you lived in Western New York during this November event of 2014, you understand that these can come at a snowfall rate of several inches per hour, and we actually received over 7 feet of snow just in a 3-day snow event. As we look also at how future days begin to change, the days under 32 degrees, right? Over time, as the climate begins to warm, we expect to see fewer and fewer days below freezing. So moving from 133 days per year, for instance, in Rochester, New York, to somewhere between 99 and 116 days in this coming decade, dropping off pretty significantly in the 2050s and dropping down in the future. Why this is important is it certainly changes how soils begin to deal with that freeze-thaw cycle, how our buildings begin to deal with the freeze-thaw cycle, but also not having the protracted periods of cold can actually increase the amount of pests and things that we see in the built environment and doing damage to our buildings and cities. Sea level rise is certainly an issue that many people are concerned about, especially on the eastern portions of New York State. In the past, sea level rise was somewhere between 0.3 of an inch and 0.4 of an inch per decade, but now we see in places like the tidal Hudson Valley about 1.2 inches per decade, and that rate seems to be increasing. The ranges are fairly wide in terms of what we expect, so seeing between 1 and 10 inches in the 2020s is not out of the question, but as we get out towards the end of the century, we're talking about potentially as much as 5 feet of sea level rise in places from New York City going all the way up to Albany, New York, all the way up to the Troy Dam. As those sea levels rise and we see as the ocean continues to rise, we have the potential for increased coastal flooding during storms, something like what happened with Hurricane Sandy, and that's something that also can increase with frequency, intensity, and duration. And again, if we just look at the tables on where some of these levels are expected to go, certainly, we're looking at less than a foot potentially in the next decade. But as we move into the 2050s and we move out into the 2080s, we potentially see really, really different coastal environments and things that we need to begin to address. Finally, heat waves. Heat waves may not seem like an important issue, but the CDC actually estimates that heat waves kill more people every year than any other type of natural disaster. It actually kills more people than all of the other types of natural hazards combined. Why we're concerned about this in places like New York is that these temperatures have been rising each decade over the past century, and we expect them to continue to rise more quickly in the coming decades, with the greatest warming projected to occur in northern parts of the state. It's an issue because many parts of the Adirondacks, Tug Hill Plateau, and places like Buffalo actually currently don't have air conditioning in buildings, so certainly these heat waves can really disproportionately affect some of those environments. We expect to see some pretty significant temperature increases in the average temperatures across New York State, so between 2 and 3.5 degrees by the 2020s, but as much as 10 degrees Fahrenheit shift by the 2080s. And if we think about our buildings, and the fact that what we build today may well last into the 2080s, it's something that we need to begin to incorporate and think about in design. Summers are expected to become more intense, and the winters themselves are expected to become milder, but these summer conditions can arrive much earlier and last longer into the fall. And certainly that can continue to stress some of the infrastructure, electric infrastructure, et cetera. As we look at some of the future days over 90 that we're going to see across New York State, right, there's a marginal increase in the number of days that we'll see in the 2020s. So in each of the regions, we're starting to see a jump in that. But if you go from the 2050s to the 2080s and you compare something like Rochester, New York now with an average of 8 days of a year over 90 degrees to what it could be in the future in a high range of 73 days a year, even a low range of 22 days a year. This is a really significantly different climate that we're going to be planning for and thinking about in our buildings. We're also looking at an increase in the number of heat waves. So heat waves are defined as when you have 3 consecutive days over 90 degrees. It's not something that is as common in upstate New York. So we typically have 1 heat wave or less per year in each of the 6 climate zones in upstate New York. New York City, however, currently has about 2 per year. But again, as we look over time, going from 0 in some cases to a chance of having 2 or even 4 per year to the 2050s and then out to the 2080s, having 8 heat waves per year in a place like Rochester, New York is really signaling that we potentially have to think differently about how we're keeping occupants cool in our buildings to protect their health. One of the important things also about heat waves is that the duration of these things are expected to change over time. So right now, typically across the state, most heat waves are between 3 and 4 days long. There's some change in that between now in this coming decade, but as we look to the 2080s, again, thinking about having heat waves that last 6, 7, 8 days long is really something that would tax air conditioning infrastructure, tax energy infrastructure, and also potentially impact air quality. So designing for that now becomes important to adapt to some of these things coming down the road. So I want to make a little bit of a transition here now to talk about the effects of some of these impacts on buildings. One of the important things to keep in mind is that buildings have certainly links with infrastructure, energy infrastructure, water infrastructure, sewer infrastructure, and our occupants in the buildings really depend on that to provide shelter. But as the climate begins to impact our buildings, we have the possibility of having cascading effects that really can cause significant damage to the buildings and certainly also impact the effects on occupants. A cascading effect is something that occurs when a failure in one system triggers a failure in another. So you can think of this as something like when you lose power in a building and you don't have any kind of system to back that up, you may then begin to lose things like refrigeration and cooling in the building if that hasn't been accounted for. And certainly that can begin to cause major problems for the building occupants, especially if they're in a vulnerable community. But the buildings can help to help decouple some of these risks from the community scale. So if you think about some of the things that are common in green building, like green roofs, those can have impacts to lower the total outdoor air temperature, lower the urban heat island effect, reduce total cooling energy, and also capture rainwater. And since we've talked about the issues of things like heat waves and precipitation, right, all going together, looking for those types of strategies that can really help reduce those cascading effects is pretty important. So I'm going to go through and just briefly talk about some of the impacts on buildings from some of these different hazards I had mentioned in the earlier part of the presentation. Hurricanes and tropical storms certainly bring high winds, intense rainfall in coastal areas, storm surge. These damages actually cause problems to buildings in three main ways. The first is actually that it causes direct damage to the building. So if a building is blown off of its foundation or turns off of the foundation, the structural frame racks and falls over, or something like roof uplift occurs. The second impact is something from windborne debris, usually to brittle materials like glass. So you imagine different things being blown into the glass in the building, and that can actually start to cause a cascading failure of building systems. In the final way, and one of the things that many people don't think about, is actually that other other structures or trees may actually be blown into buildings. And actually, this is one of the primary ways that you start to see damage and impacts from things like tropical storms. In the case of flooding, which is something that can go along with tropical storms or can be caused just by intense precipitation, right? This is one of the most significant climate change threats to buildings. And as you look across New York State, again, this is something that has actually affected all 62 counties of New York State. We have approximately 700,000 people in New York State living in flood-prone locations, and millions more people work, travel through, or play in flood-prone areas. Things like sea level rise coupled with storm surge and flooding can definitely inundate roads, isolate communities, and damage buildings and infrastructure. Again, although that's something that people primarily think about as being just in the Atlantic Ocean, it's something that extends all the way up to Albany, New York, all the way up to the Troy Dam, because the Hudson River really is actually a tidal river. The impacts we expect to be greatest in the urban areas with high percentages of impervious surfaces, because there's little capacity for all of that additional soil to actually hold that excess water. And it's certainly something, flooding, that it can have multiple economic impacts on the building sector. So certainly we see damage to buildings, but we also see disruption to businesses, and we see things like waterborne diseases that actually can come and affect the health sector after we've had some of these events. As we look at severe storms across New York State, again, these storms bring high winds and intense rainfall, which can directly do damage to buildings. As precipitation levels increase, we expect that building failures and flooding will also increase, and wind-driven rain may drive rain through roofs, through walls, apertures, and certain types of foundation. These damages will actually potentially create cascading risk. So when an envelope is actually breached by wind-driven rain or high winds, it can cause cladding systems to fail, as well as beginning to do long-term damage to the structure, building systems, the contents of the building, and the occupants. Finally, winter storms. So So in the areas of the state that may see increased winter precipitation, certainly we see things like roof loading due to larger snowfalls. Again, the Great Lakes are warmer, they actually can carry more precipitation into places like Buffalo, Syracuse, and Rochester. Certainly during Snowmember here in Buffalo, we saw a number of roofs collapse, and it actually resulted in quite a significant loss of life and property. Other types of damage, though, that can change because of changes in freeze-thaw cycles are things like ice dam formation. Certainly, those freeze-thaw cycles increasing can actually damage roof eaves and allow water to get into buildings. Snow buildup at building perimeters can drive additional moisture into wall assemblies. And certainly, also with changing temperatures, we can see things like increased number of ice storms in the state, and the snow and ice accumulation that can happen on trees or power lines may impact electrical distribution at the community level, causing power outages, which actually can lead to additional cascading failures in the buildings. Impacts of sea level rise. So in some of the coastal and tidal areas of the state, these levees and seawalls may be overtopped or undermined, something like what we saw with Hurricane Katrina in New Orleans, where certainly entire areas were inundated when levees failed, and also what we're seeing right now in parts of the Midwest. Other water control infrastructure may be overwhelmed, which can cause more damage to buildings. Increased erosion from sea level rise may also shift how we begin to position buildings and begin to destabilize existing foundations or even the buildings that we're putting in now. When you're talking about something like 5 feet of sea level rise over time, those buildings that are in those plains right now certainly may be affected in the long term. As we look at heat waves, increasing outdoor temperatures are something that we expect will impact the indoor environment. It's also something that we think will impact how buildings are operated. Warmer and more humid conditions are going to increase energy demand, especially for electricity and mechanical cooling. And potentially because those buildings, through their air conditioning systems, are driving and expelling the heat from the building, you see localized impacts on the urban heat island. But also, if we're drawing the power for those systems from greenhouse gas emitting electrical infrastructure, we'll see more fossil fuels driving additional climate change in the future. One of the critical things we have to think about is that many buildings we live and work in today have no means of natural ventilation if there is a power outage, let alone space cooling. It's not to say that we need to make sure that every building has a generator as a backup, but it's something that we need to think about how these buildings might operate if we don't have power. And on the exteriors of buildings, as we see increased heat waves, we may begin to see reductions in the service life of certain building cladding materials. Certainly, temperature shocks to things like roofing material can really reduce the overall lifespan of those. And outside, as we see driving higher temperatures, an intensified urban heat island may further impact the demand for cooling. So all of these solutions need to begin to come together. Certainly, just having something like air conditioning may actually cause greater problems for other people surrounding the buildings. So I want to make a little bit of a transition now to talking about some of the strategies in the last 10 minutes or so of this presentation. We actually have a two-part webinar that's coming up that is going to get into these strategies in much more detail. If you're interested in what we're starting to talk about in terms of these adaptation strategies, really would encourage you to call in for that two-part presentation, because we'll be able to get into this in much greater detail. So a critical part of the adaptation process is identifying and developing strategies or measures for buildings. I think this is something that's very familiar to architects and engineers working in the built environment. We often talk about energy efficiency measures, energy efficiency strategies, or other green building strategies. It's a very similar idea, except that we're really trying to limit exposure to risk and take advantage of some of the opportunities. So if we're looking at things in the building like increased insulation, it's certainly something that can help us with greenhouse gas emissions reductions, but potentially also helps us to think about maybe reducing temperatures indoors if we do have some of those heat waves. It's something that we can't say applies to every region or every project of the state. It really is something on a regional by regional basis and a project by project basis. It really requires good professional judgment to make sure that we're making these things work. So how we think about these and how we prioritize investments over time is certainly something that we need to think about. How long the building is going to last, what the program, what the mission of the building is, what its importance is to the community, and also what materials and systems we're planning to use to build that building. An important thing to point out is that adaptation, especially in the long term, is only needed for buildings that will still be standing and usable when the climate change impacts occur. So on our campus, for instance, we have a number of temporary buildings that are expected to come down in the next 5 years. It may not be critical to think about climate adaptation issues for those buildings because they'll be gone before the most significant impacts happen. But for other things, like the building we're in right now, which is called Hayes Hall at the University of Buffalo, it's been around since the 1860s, and so thinking about how, for another 150 years, this building, what it's going to need to respond to, it's a very significantly different set of circumstances. One of the challenges to the profession is that adaptation is not something that always has a clear and certain short-term return on investment. Right now, a lot of the people who are thinking about climate change adaptation are public entities or places like university campuses, which are not going to be relocating and really are in it for the long run. The challenge going forward is making sure that some of the buildings and building owners who want a shorter term return on investment beginning to make that business case. Some of the strategies that have collateral public benefits, like reducing the urban heat island effect or reducing stormwater quality issues, may be easier to implement. And so looking for those overlaps between green building and climate adaptation is a really important part of this process going forward. To that end, we can actually think about adaptation strategies in a couple of different categories. The first category is really just preparing a building for new or increased hazards in the future. But a no-regret approach is actually looking for something that actually provides auxiliary benefits. So again, what we mean by that is if you think about something like a green roof on the building, it can actually help to reduce the total greenhouse gas emissions from the building by increasing the energy performance, in addition to doing something like beginning to adapt to increase rainfall that you see on a site and reducing that water going into the stormwater systems. Some of these strategies certainly dovetail with sustainable and energy efficient design practices. And so a lot of what we already do for things like the LEED rating system or for green building or for energy efficiency can help us in the long run. And prioritizing those things up front, especially the ones that are going to last the longest, is really an important part of this adaptation process. So some of the adaptations we talk about for hurricanes and tropical storms, and again, this is just a very broad overview. We'll be getting into this in more detail in a two-part series. The most critical design response to these storms is to establish a continuous load path and to make sure the walls, floor, roof, and foundation is all connected. Holistically looking at this is important. So if you only think about strength in one area, like you increase the ability of windows to actually withstand hurricane force winds, it may only change the mode of failure. So in some cases, people put in resistant windows, but they actually get torn out of the walls in that case because the walls haven't been upgraded. Or the envelope gets upgraded, but the roof hasn't been looked at, and then the roof gets torn off of the building and you still have a problem. You really have to look at all of these issues holistically. One of the things from a design standpoint is looking at how the building performs aerodynamically, what the massing of it is, what types of roof forms you use can help deflect high winds and protect the roof walls and openings of the building. And things like hurricane shutters can also help to protect the building openings. Thinking about glazing really can also prevent life safety hazards of things like broken glass within the space. One of the things we also saw in many cases in Hurricane Sandy is having backup power and making sure that that backup power is out of the floodplain, because this can help to ensure continuity during the hurricanes and tropical storms and help to recover much more quickly. As we think about flooding, flooding really breaks down into 3 different categories. Retreating is about getting out of the high-risk coastal areas and maintaining setbacks from potentially hazardous areas. This is probably the only approach that really is foolproof in terms of getting away from the sources of the flooding. Accommodating is where you actually think about wet floodproofing the building, so you're allowing water to collect and to move through without causing damage to critical pieces of infrastructure or displacing people within the structure. And finally, and probably one of the most challenging things, is protecting buildings from the flooding and storm surge and constructing structures like seawalls or berms. This is something that, if you can't retreat and you can't accommodate, this is the last kind of approach, and it's something that's, again, nothing is 100% foolproof, nothing is 100% resilient. Thinking about adaptations for severe storms, roofs certainly over time, as we see that increased precipitation, need to be designed for proper drainage, and they should have sufficient slope and stiffness to prevent ponding of water on those structures. Carrying the water away from building openings and certainly from foundations if you're seeing those 1 and 2 inch rainstorms per year. Other types of protection against vapor penetration and water migration through the envelope may be necessary, and really thinking about things like below slab membranes or vapor barriers, because as you have those significant storms, certainly you see changes in water tables that can actually bring dampness up into buildings. And backup power systems may be needed to ensure continuity. Certainly in homes, something as simple as a sump pump oftentimes don't operate without a backup power system. And so you can cause flooding in the building just from, you can have that cascading failure just because of a power outage during a storm. For winter storms, even though it's kind of counterintuitive that as the climate warms, we're going to see increased snowfall events, but does strengthening the roof structures to meet some of the snow loads, and also to make sure that the snow is actually distributed evenly across the roof itself, will be important. And certainly with increased freeze-thaw cycles, protecting against ice dams to protect building materials inside the building. Also looking at cladding material durability and how it's maintained with those freeze-thaw cycles, and thinking about how you begin to carry that moisture away from the buildings so that you have the ability during significant snow thaws to minimize moisture accumulation. In Buffalo during November, it actually went from below freezing and 7 feet of snow to over 60 degrees the next day, and there was a fairly significant flooding that actually followed that snowfall event. And again, backup power supplies may be something needed to provide electricity to make sure that systems continue to operate. Finally, the last set of adaptations as we look at things like heat waves and extreme temperatures. Passive design, which is basically designing building strategies that can help make the best of the climate, and so we don't have to use mechanical equipment, is something that we really need to begin to think about incorporating into new buildings and potentially return to some of our historical buildings. One of the terms we'll be talking about in a later presentation is the idea of passive survivability, how well a building is able to keep interior temperatures without electricity. But that really starts with the basic passive design strategies that we're supposed to be talking about in architecture schools. Passive strategies go along with a high-performance envelope, so certainly as something that's part of the building over the long term, over 80, potentially 100 years, making sure that we get that system right and that it's dealing with the impacts of climate change over that long term is important to moderate some of the cooling loads. Efficient HVAC equipment certainly reduces the amount of mechanical cooling needed, reduces the amount of heat potentially that's rejected to the atmosphere, and certainly reduces the amount of greenhouse gases we have from buildings. And again, backup power supplies are certainly something that can be important, especially in mission-critical types of buildings, to make sure that those functions keep going. So that was in 50 minutes, a really quick overview of an introduction to the issue, some of the hazards, impacts, and also strategies in buildings. We're going to turn this over here in a minute to allow you to ask some questions either through the chat feature or by calling in. But again, we just want to thank NYSERDA for supporting this research over the last 3 years, giving us the opportunity to take a look at this, and certainly supporting these upcoming webinars. Also really want to thank our partner in the USGBC, New York Upstate Chapter, for their promoting this event. And I'm going to leave the next slide up here to allow people to begin to go and download some of these resources if they're interested. If you want to contact me personally, my contact information is at the bottom, ap.buffalo.edu/Rajkovich. It takes you to my faculty homepage where you can give me a call or shoot me an email if you have any questions about what we covered. So everybody is now unmuted. So if you have questions, you can start to ask questions one at a time. I see 2 questions that were put through the chat. The first one is about getting a copy of the presentation slides. So yes, we're absolutely planning to upload all of the presentation slides to the website that we showed, the ap.buffalo.edu/adapting buildings. We're also going to provide a copy, a recording of this presentation so that people can understand what's going on. One of the questions from one of the participants was also what has been done so far to work with insurance companies to incentivize businesses and residents to reduce their risk. I would say that organizations, especially like the reinsurance industry, which is the industry that actually insures the insurance industry, is spending a lot of time and effort to understand how climate change may impact the building stock. They're certainly looking at what are causing buildings to begin to fail and trying to incorporate those into their rates and their underwriting. So we haven't in particular done anything with the insurance companies, but we expect to see a lot in the next couple of years from organizations like Munich Re, which is a reinsurance company on this topic. But if there aren't any further questions, we'll just end the webinar here at 1 o'clock so everybody can jump back to work. So thank you very much.